Good morning, dear students. In the last class, I explained you about the first and second focal point or the focus, first and second focal length, and first and second focal plane in case of a convex lens. So these things I discussed in the last class. Now today we'll discuss about the same thing but in terms of concave lens. Okay. Now follow this diagram. Now let us consider this as a concave lens. O is the optical center, okay, and F1 is considered as the first focal point, or known as the first focus, or also symbolically written as F1. Okay. Now let us come to the first focal point in case of a concave lens. It is a point on the principal axis in which a ray of light appear to converge at this point. Okay, so it is a point on the principal axis in which the ray of light which is incident, the incident ray of light will falls on the lens, they appear to converge on it. So this point is known as the first focal point in case of a concave lens, also written as F1. Okay, so in F1, on this point, in the first focal point, the rays of light are actually they appear to converge. They are not actually converging. The refracted they are not converging. Okay, but what happens there? They appear to converge. They appear to meet, and that point is considered to be as a first focal point in case of a concave lens. And the distance between the optical center and the first focal point is known as the first focal length. And also the plane passing through the first focal point and the perpendicular distance between the principal axis known as the first focal plane in case of a concave lens. So this is about the first focal point, first focal length, and the first focal plane in case of a concave lens. Now second one. Now this second focal point, it is a point on the principal axis in which a beam of light which are parallel to the principal axis, they appear to diverge from it. That means the ray of light are diverging from this point. Okay, so this point are considered as the second focal point. Okay, so and in the second focal point, the rays of light appear to diverge, but in the first focal point, the ray of light appear to converge. So that is the difference here. And the distance between the optical center and the second focal point is known as the second focal length. Is known as the second focal length. And the plane passing through the second focal point and the perpendicular distance of the principal axis is known as the second focal plane in case of a concave lens. Okay. Now after this we come to the some important point, that is about the real focus and the virtual focus. Okay. So what are the real focus and the virtual focus? Let us consider a convex lens. You know the convex lens. Okay. And this is the principal axis here. This is the optical center. A beam of light which are parallel to principal axis. And after refraction, what will happen? These rays of light, they will meet at one point. Is it clear? They will meet at one point, and that point is considered as second focus. Okay, because in the second focus, in case of a second focus, in case of a convex lens, the second focus will be on the right hand side. Okay, first focus will be on the left hand side, but here it is just opposite. Okay, so let us consider in case of a convex lens, where a beam of light is parallel to the principal axis. Okay, the ray of light after refraction, all the ray of light they will converge at a point, and that point is called the focus, or also known as the second focus or the second focal point. That means these are refracted rays, they will meet at a second focal point. Okay, now this second focal point are considered, now this F2 is considered as a real focus. This is considered as a real focus, and also the focal length is also becomes positive. Here the focal length is also positive, and the lens is considered to be as a positive lens. The lens is positive, focal length is also positive. Okay, and F2 is the focal point. also known as the focus. So this is known as the real focus. So F is considered as a real focus in case of a convex lens. So second one, follow this diagram again. The parallel beam of light, the beam of light which are parallel to the principal axis, they appear to diverge from it. That means they will appear to diverge from F2. Okay, so when they appear to diverge from F2, now this F2 is considered as a virtual focus now. It is known as the virtual focus, and the focal length is also become negative, and the lens is negative. So concave lens is negative because the virtual focus is forming. Okay, and the focal length is also negative. Okay, so these are the points. Okay, then and the next point is also there. The second focal point, remember, the second focal point is also called the focus. Second focal point, that means this F2 is known as the focus. Second focal point is known as the focus, also known as the focal point. These are known as the focus or the focal point. Second focal point, that is the second focal point, F2 is known as the focus, also known as the focal point. Remember that. Then again, other one is there, the second focal length. Again, second focal length is F2. This one, smaller to F2. Second focal length is known as the focal length of the lens. This is known as the focal length of the lens. Focal length of a lens. Okay, so remember this point here. The second focus, that means F2. Okay, second focus or known as the second focal point is known as the focus, or they are known as the focal point. Then again, second focal length is known as the focal length. Okay, second focal length is known as the focal length. Okay, then what happens is that F1 is equals to F2. That means the F1 can be considered as F2 when they are at equal distance, when the focal length are equal distance from the optical center. That means, suppose if I consider this is the convex lens, okay, optical center. So this can be F1, this can be F2. Okay, so what happens is that now this F1 and F2 can become equal when this F1 and F2, that means this focal length will be at equal distance from the optical center. If the distance are same between the F1 and F2, then I can write here F1 equals to F2. So these are the points you have to remember. Okay, now the last one will come to the last, we'll discuss the last part here. That is about the refraction of an oblique parallel beam of light. Refraction by the oblique parallel beam of light to the lens. Now follow this diagram. Now what happens is that now these are the beam of light, okay, which are not parallel to the principal axis. These are the beam of light, okay, which are not parallel to principal axis, but this beam of light will form some angle. Okay, they will form some angle with the principal axis. Okay, they are not parallel to each other. You can see the rays here. See, these rays are coming slanting. They are coming obliquely. Okay, oblique parallel we call it here. So they are not parallel, but they will form some angles. And now these rays, this refracted ray will not meet at one point. That means they will not meet at the point F2. They will not meet at some fixed point. Okay, but this refracted ray will meet on a plane, which we call it as a focal plane. Okay, this refracted ray will meet at a focal plane in case of a convex lens. Okay, sir. But actually, what should happen is that when a beam of light, in case of a convex lens, a beam of light, when they are parallel to the principal axis, after refraction, they should meet at F2. That means they should meet at a focus or the second focal point. But here the refracted ray, they are not meeting or they are not converging at one fixed point, but instead they are meeting at a focal plane here. That means at a point B. Okay, so this way the refraction of light in case of a convex lens is taking place. That means the ray of light which is obliquely parallel to the lens. Second point again these are the oblique beam of light, okay, which are not parallel to the principal axis, okay. And here also what happens, the rays of light, okay, they diverge. The rays of light will diverge. And now this ray of light, when they are produced backward, they appear to meet at B. Okay, these are the obliquely parallel beam of light. That means they are not parallel actually, but they are making some angle with the principal axis. Okay, so these rays of light they get diverged, and these rays of light, these divergent rays of light, when they are produced backward, that means these refracted rays when they are produced backward, they will meet at point B. And when the ray of light passes to the optical center, see this one. When the ray of light passes to the optical center, the ray of light passes undeviated. So that is why I have drawn only two rays here. Third ray is not here because the ray of light passes to optical center, and after refraction also when they are produced backward, they follow the same path here. Okay? So remember that when the ray of light passes to the optical center, after refraction, the ray of light passes undeviated. That means the ray of light passes to the same line. Okay? So now this refracted ray, this one and the lower one, in fact, they are produced backward and they are meeting. And the middle one also, they are coming at the same line here. So the three rays are meeting at a point. They are produced backward, meeting at a point B. And these refracted ray are not actually meeting at some fixed point. They are not meeting at the first focus, neither at the second focus. But they are meeting at the focal plane here. So therefore, in case of a concave lens, okay, when the refraction takes place by obliquely parallel beam of light, these are the conditions takes place. So we have come to the end of this portion, okay, and till 100 and last time I told you that page number till 101 we have to study. Please go through it, okay, entirely inside the book, okay, whatever I have discussed, whatever I have explained, you please go through it and do your exams well and prepare well.